We've just started recording. Welcome to the ESIP IT&I Tech Stack Working Group. So this is a combined event that includes individuals from the ESIP IT&I and the CDI Tech Stack Working Group. Today, we're really happy to have Josh Trahern and Andrew Bulen. I believe we have Jeremiah Grief on as well, who will be helping to guide us through the presentation once we get through the introduction slides. If we can just go ahead and go to the next slide, please. So just a quick introduction. This is a combined group. This is the ESIP IT and Interoperability Program Committee and the USGS Community for Data Integration Tech Stack Working Group. The co-chairs of this are myself, Derek Masaki. I'm with USGS NGTOC, Tom Sawyer with USGS Eros, and Kevin Wood over at USGS NGTalk with myself. We are hello? Somebody say something? Okay. We are taking over from Rick Signell and Dave Blodgett, who have been running this for the past 2 years. I'm really grateful for this opportunity to be able to use this forum to present information that aligns with both the earth science portion of the group and with the tech stack portion of the group. And so I'm hoping to kind of strike a balance between these two. Today with the elevation group, they're perfectly situated because we've got an exciting tech stack that's emerging as we've been re-architecting, and there's of course the earth science output, the 3D elevation program data resources. Next slide. So just a quick introduction. I'm with the USGS National Geospatial Technical Operations Center. We just say NGTOC, and really the NGTOC is the technical program that supports the national map, and we are responding to guidance from the National Geospatial Program, our USGS headquarters program. So the NGP and the NGTalk work very closely together, one providing the guidance, the other providing the technical support. Next slide. Wanted to provide the earth science information links that we provide and deliver, and that includes the National Map Services, the 3D elevation products that you can retrieve through the TNM downloader. I also sent this out in an earlier email to the group, so hopefully you'll have that as direct links. The 3D Explorer, and then just a little bit of more information. We do have a geo narrative that's kind of like a story map that provides an overview of the 3D elevation program. And I hope that everyone is able to hit those links, try them out, look at the download features and services that we do have and support. Next slide. And then the second portion of this, of course, is the tech stack. So what Josh is going to provide an overview of, along with Andrew, is really this containerized application that uses Kubernetes as the containerized orchestration platform. There is an open source component because this is all built on open source tools and backend. And then the hardware element, so this full tech stack of application down to infrastructure. The product itself runs on VxRail appliances. This is a Dell EMC hardware solution. And the solution is what's, I think the buzzword is hyperconverged infrastructure. And that hyperconverged infrastructure brings software-defined IT infrastructure that many of us are familiar with, VMware. So these are virtualized environments running on that hardware. Software-defined storage, which many of us are not as familiar with, and that's a Dell EMC Isilon virtualized storage system that allows you to have a single mount point for many drives that are providing petabytes of data storage. And then finally, the virtualized networking component that brings that all together, and that is a Dell EMC virtualization overlay that allows you to connect many virtual LANs into one and connect that out to the WAN. All right, next slide. So the elevation products themselves have to run through really a delivery, so we can get that raw point cloud data from our contractors. That goes through a validation process. The elevation team, the software team develops the validation tools. There's a correction cycle where we have to review and then kick back anything that needs to be reprocessed so that we can bring it back into our system. And then finally, we have the processing, that the Elevate product that Josh and Andrew are going to describe, and then it gets pushed out to the endpoints that we just saw in those links, and that's how we distribute and publish those 3D elevation products that you can retrieve through the many services that we make available. Next slide. Can we go to the next slide?
And for some reason, it's
no problem. Oh, yep. Okay. Yep. So with that's sort of the end of my introduction. I really want to thank Josh Trahern and Andrew Bulen, who took on a lot of the burden of putting this presentation together. We have Josh as the project manager for our elevation software development team, and Andrew Bulen, our lead developer. We also have a couple others that I hope we can call out as we go through the presentation. So if Jeremiah is available, it would be great. And if we have anyone from the IT side, it would be nice for us to be able to allow them to speak if possible. So if you can just check that you're mic'd up and then you have an ability to come off of mute, that'd be great. With that, I'll let Josh and Andrew take over from here.
Okay, hi everybody. I'm Josh. I'm gonna come over here to Andrew's slides. I'm just gonna give a brief overview of kind of what Andrew's gonna be talking about here during this presentation. Elevate is a web application. Previously, it was a desktop application that we used to basically guide our users through the product generation process and handle processing that data that's been validated through our QC process into the products that we distribute. And over the last few years, kind of starting around 2016, 2017, we started looking at changing out pieces of COTS software with open source alternatives. We were kind of running into some issues with the tool set we were using previously, and we're just curious if we can make any improvements to our efficiency and our run times by swapping out and looking at open source alternatives. And so gradually over the years, we got to a point where we were essentially 100% open source, at least for the Elevate application. And that kind of, we hit that milestone around the end of 2019. And then this last year, we spent most of the year, we reevaluated the environment we were running these open source tools in. We were using Esri Workflow Manager, and we realized that now that we were 100% open source, we didn't need to be in that environment anymore. And we worked with IT, and Andrew really led this effort to identify what improvements we could be making in terms of how we were utilizing the hardware that was available to us, and if there were any improvements that we could make there to efficiency. And long story short, we did. And Andrew is going to talk about how we made those steps over this last year and how we kind of got to that point. So Andrew, if you're ready.
Oh, sorry, I lost my connection there for a second. Can you hear me?
Yep.
Ah, awesome. All right, I guess we want to move on to the next slide.
Yep.
Okay, so kind of just a general overview of what I'm going to cover, similar to what Josh just said. I'll go over some of the commercial software transition into open source, how we transitioned our SD database to PostGIS, and then ended up adding in some task queuing and running everything inside containers, and then finish up with some questions. Next, please. Okay, our transition to open source from COD software. What kind of prompted this is I listed out some of the issues, some of the main issues that we had in our first version. That one, I think, was around 2014 when we started production on that version, and it was entirely ArcObject running in WMX custom steps. GP tools, file locks, COM objects, those were probably the biggest headaches that we had kind of recurring. And there was a few instances where we had requests for functionalities that we just could not produce with ArcObjects or produce accurately enough to meet our standards, I guess. So the solutions that we investigated for some of those at first, the big one we did for GP tools, we had a lot of issues with those, primarily when we were running tools that would either disconnect workspace connections that we had, release COM objects when we didn't want them to, or leave COM object connections so we couldn't access resources after they'd ran. So we kind of wrote a separate tool that you could pass the name of the GP tool you wanted to run with any arguments. And then from WMX, we would spawn that tool in an external process. So when the GP tool finished, it would clean up all of its resources. And then we could continue on in our WMX code without having any issues. Unfortunately, with some of the other stuff, there was no good way to get around it. There were certain instances where you just have a file lock that does not want to go away, or a workspace that you cannot open because of various reasons. Unfortunately, at times it came down to we had to close every instance of software we had running on all of the systems, and sometimes had to reboot all of our production systems in order to get those locks to release. Another thing we did was we wrote some wrappers around things, particularly like workspace objects, that would check to make sure that the COM object is still there and connected to it each time you access it. And if it wasn't, it would reconnect to it. So that helped with a lot of the issues too. And then finally, when we couldn't find any good solution, we started looking into other alternatives, and primarily open source. Next slide, please. Okay, for our first one, the first tool that we came across that we didn't really have a good option was our silhouette generation. Oh, I just closed it out on me. 1 second. For this, if I remember correctly, the primary issue we were having here was that the existing tools to create an outline of a raster was leaving out certain areas of no data, I guess including it in the bounding polygon, and we couldn't get it to accurately represent the geometry that we wanted. So we looked into using writing our own tool with GDAL and Ogre that would iterate over a raster file and create a polygon for all of the valid pixels within that. And coincidentally, it performed significantly faster than the other tools that we were trying to accomplish this with. And it produced an extremely accurate silhouette along the boundary of that raster data. And a little note there, we ended up having it working a little too precisely on some of our high resolution rasters. We were getting very accurate geometries that had a lot of points in them. So we eventually had to go back in and add some simplification to that to reduce the size of our output shape files. Next one. Another simple tool we created, this one's very basic, but it's just for modifying no data values within a raster data set. We standardize the no data value on all of the products that we distribute, and we get data from various locations between contracts and distributed and everything, and they're not always using the same no data value. We originally were accomplishing this with map algebra. With map algebra, but the downside to that was you had to write to a new file, and it is a very slow tool. So we went back to GDAL on that one, and it turned out to be really easy to just open up the raster in place, update the header value, and then iterate over all the pixels and replace them with the correct no data value that we wanted to. Next, please. And the last big one was kind of our spatial metadata tools. We iterate over all of our input products. So like when we receive either LiDAR files or raster files from the contractors, we go over those and use the extents from each of the tiles that we distribute and create spatial metadata and populate it with all of the project information. And with our Arc Objects code, this was one of the lengthiest parts of the process. It was very slow opening up all of the files, getting all the information we needed. So we kind of did similar approach here, wrote tools in GeoTools and Ogre that would iterate over all of them and dump everything to a temporary shapefile. And then from our WMX code, we would just import the features from that shapefile into our database. Next, please. And then command line tools that we found, like the more we messed around with open source tools, the more we found sort of one-to-one transitions from our Arc Objects and GP tools to open source command line tools. Listed out a few examples here. Copy raster from the copy raster GP tool can be replaced with either GDAL translate or GDAL warp, depending on what you're wanting it to do. We ended up replacing mosaic datasets with a virtual raster table, map algebra with GDAL calc, and copy features with Ogre to Ogre. And we finally, when we hit our 2 gig limit on shapefiles, replaced all of those with geo packages. These are just a couple examples. I ran these tools on the same input data set. That was it 343 megabyte raster files, just to kind of show some of the differences that we got in speed performance. With just a simple copying raster to a different format, see here, it took 63 seconds with copy raster, and the same one took 6 seconds with translate. Updating aspects of the raster itself with copy raster, change the no data value and the pixel type, 54 seconds, almost 55, down to just under 14 seconds. And the Create Mosaic data set, this one's not well, I guess percentage-wise it's big, but in this example, I created a mosaic data set and then just added a single raster to it. And that took about 9 seconds, whereas building a VRT took a little over 1/10 of a second. The big difference here is that build VRT command, you can pass a wildcard like I have it shown here, and it'll add every single raster that's in that directory matching that wildcard. With what we had with Create Mosaic Dataset, we had to go through all of the rasters and add them all to there, and it was very time consuming. Next one. Similar thing with vector. This is a basic translating a feature class to another feature class. I forget which, this was one of our spatial metadata products that we output. I don't remember which one it was exactly, but it was 586 megabyte shapefile that with the GP tool took 16 minutes to copy to another shapefile, and using Ogre to Ogre took 2.5 minutes. Next, please. So what we finally ended up with, like Josh was saying, we had a bunch of external tools that we were calling from within WMX itself. Initially, we kept WMX because we needed all of our database feature classes were stored in an SDE database, and we used WMX to interact, copying in and out most of the data that we store in those feature classes. Most of our external processes, we had a very generic workflow step wrapper that would kind of pull out the information we needed from the database and then call its corresponding external tool to achieve whatever output we needed, and then read any outputs that we needed to store back into the database after the external tool had completed. Next, please. And because of that dependency, we started looking into replacing our SDE database with an alternative, and we ended up going with Postgres with PostGIS. One of the big perks to that is it allows direct access from anything other than Esri, and you can still access it with Esri. That was one of our big issues. We were still dependent on WMX for a lot of the, especially the writing. GDAL and some other tools will read from an SDE database, but there's very little support for writing into it. So by switching to PostGIS, it kind of gave us universal access with whatever tools we wanted to use. Next, please. Okay, so when we first started this, we were just looking at setting up kind of a REST API for interacting with our PostGIS database. I guess initially we were going to try to replace the database and then move data back and forth through the API with our WMX steps. So when we got to working on that, we ended up settling on using Django for the web framework and added in the GeoDjango support and the Django REST framework plugin. They're both extremely useful, very simple to set up and use, and relatively quick to get a functioning API up and running. Next, please. This is a very simple example of one of the models. So this is just a reference state feature class that we use for intersecting with different products and stuff. But as you can see, it's very basic. The top left is where we declare all of our model information, basically all of the fields that we want to store in the database. Then one below that is the serializer that's used with that model. All you have to do is tell it which model you're using, the geometry field, and then there's some other stuff that you can specify, but it's pretty straightforward as well. And then the top right, you have a view set, which you can specify your query set for that model instance that you want to include. This one is just taking everything, but you can modify that to be any subset you want. And then the serializer you want to use for it and any permissions. And then you register that view set in a router and add it to your project URLs. And that will add in a list view for all of the instances of that model you have, as well as detail views. So you can dig down clear to like a single instance of a state in this example and view its geometry name, any extra information you want with it. Next, please. Okay. So after we got the API up and running, got to digging into automating some tasks to run. There's some that we wanted to go ahead and run before the users got started running processes. And in looking into that, it actually turned out to be not too complicated of a process to set up. So we ended up looking into Celery for running those distributed tasks. And the nice part about it, we were already using Django, and it out of the box has support for Django applications. Very few things that you actually have to specify. I'll show that in the next slide. And we've had some experience with Rabbit on other projects, so we just tied it into that as well, using Rabbit as our message broker between the web interface and the worker processes. Next. Yeah, these are basically everything that you need to set up and run Celery within a Django application. The snippet on the left is the entirety of our Celery module that we add into our app source, telling it where to pull settings from, to creating the app, and telling it to discover any tasks within that app. And in our main Django settings file, anything prefixed with the Celery underscore gets translated into configuring the Celery processes. So that's all it actually takes to include Celery with a Django application. Next, please. Once again, it's kind of a simple example, but it fits on the screen. This is one of the tasks that we created to run within our Celery and Celery workers. What this is the raster tools library is something that we have set up that has all of the lower level code, but we're creating our task instance to take an input raster data set and translate it into a COG formatted TIFF, and then calling that, adding the apply async function on that with any arguments, specifying which queue you want it to go to, and optional priority. Next, please. What we ended up with. This is kind of a diagram of how it works. We have the website interface for users. They click a button and it creates that task. We store any pertinent information about that task in our database, and then it gets shipped off to RabbitMQ, and then our worker processes watch the queues. Anytime there's a new one, it pulls it out, executes that process, and stores the results in the database. Next. This is kind of a example overview of what we currently have running in our production system. We have our web interface running where you can select any number of tasks to start running. We currently have 6 separate queues that we keep in our RabbitMQ instance, just to kind of give priority so we don't have one project type hogging up all of the CPUs and keeping others from being processed. And then each worker that we have will pull from that queue and just keep going round and round. The nice part about this is with each one of those workers that I have labeled, each one of them can pull one task apiece from each of the 6 queues. Like in this instance, the only extra I added was that task 7 in the default queue. So the first worker will pull its first task from the OPR queue, and then all the others get distributed accordingly. And that default worker will go back to the Celery worker 1 and run at the same time as the OPR task. Next, please. Okay, the Docker side. Once we got all of our app source up and running, we decided to move towards a containerized environment. And in order to get there, we ended up setting up several Docker images. One of the other developers, Phil Thiem, did a great job for getting us started on some of these lower level Docker images. The base image one is just a Ubuntu base image that's currently 1804. That has some extra logging and init script stuff added to it. And then he built the passenger Docker image as well, which adds a passenger nginx to Ubuntu. And then the app server image and the app worker images are very similar. Well, they're made to work together. The app server one is sitting on top of passenger Docker, but it's tailored specifically for Python applications, and it's set up in a way that you basically drop in your app source code and it will run the website for you. The Celery one is the same thing with the Celery side of that. It has all of this stuff, all of the dependent Celery packages and everything already in it. So you drop your app source into it and it'll spin up Celery workers based off some environment variables that you pass in. The GIS image we built, that one's kind of intermediate step that we use for ensuring that we're all on the same version of open source packages, as well as building some of our in-house tools that we develop both for product generation and validation. And then finally, for this project, we have the Elevate Web one, which is adding our Django app source into that app server image, and our worker one, which combines all of the built packages in the GIS image into the app worker Celery image, and then adds the app source in. Next, please. Okay, for testing, we use Docker Compose. We have a pretty beefy machine that we use for a combination of testing and dev. So for that one, we spin up a Postgres container for our database to use for testing, a separate RabbitMQ instance for them, as well as a GeoServer container, a web container, and then a couple worker containers for them to test on. Next, please. And our production environment. For that, we wanted a little bit more robust than Docker Compose. So we ended up setting up a Kubernetes cluster. It's built entirely on 8 VMs that IT set up for us. Each one of them is 10 cores and 128 gigs of RAM. We set up one master node and have our web containers running on that node, as well as a proxy. And then we have several worker nodes that we distribute our worker containers and GeoServer containers across. Okay, configuration with Kubernetes, if you're not familiar, it's extremely handy. We utilize both secrets and config maps for setting up our pods. The secrets, everything from database credentials, user access, anything that we need that we don't want to store in a Git repository or have openly accessible in the config map, we store in there. And the config maps are primarily setting up various environment variables for the different containers. Next, please. And then for deploying an actual service, we specify deployment and how many replicas you want. For the web, we have 1. Workers, we're currently using 6. And then specify your image you want, any metadata, pull your environment variables from your config maps or secrets, mounts, and for instance, like the web, since we want it running on the master, we use node selector for that one. And then a service to map all of our pods into a single node port. Next, please. And what we finally ended up with is currently we're using a Postgres database that's sitting on NetD1. Somebody from IT might have to correct me on this one, but I think that's a virtual database machine. And then we have RabbitMQ that's running on a virtual machine. Somebody correcting me on that. Okay. And then for the Kubernetes, we deploy our 1 web container and 6 workers in a GeoServer container. Next, please. This is my graphic for roughly what we have running in production. The reason we've stuck with 1 web container so far, I guess I didn't explain that in the passenger part. Passenger is really handy because you can set it to auto scale. And within that container, it will, I think it initially starts up 3 instances of your WSGI application and will scale up to, I think I have it maxing at 20. So it kind of handles the scalability internally if we get high traffic. And then with the workers, we have 6 of those running a process for each queue that we have in Rabbit. Next. Yeah.
Okay, that kind of wraps up the really down on the weeds view that Andrew was given. Now I'm going to jump back in and show you kind of how this application's evolved over the years and how it's compared to previous years' goals and actual production numbers. So the metrics over here on the left are the total area produced in a year. In the blue, you have the goal production number, and then in the orange, you have the actual square mileage that was produced. And so, like we said at the start, transition to open source kind of kicked off around the end of FY17, and you can see why we were motivated to do that. Up with our goal, and our operations group wasn't able to hit that goal that year. And so we realized, we needed to make some improvements to the tools we had that were supporting them. It sounds like someone's mic might be unmuted, if you don't mind checking that. So in FY18, we had made quite a few at that point, we had transitioned a lot of our standalone tools over to open source. That was the kind of tools that Andrew was talking about at the beginning. And we saw a significant increase in productivity, and that was carried over into FY19 as well. One of the things to mention here is, kind of the limitation of area as a metric for tracking these. Each of these years, the last 3 of these, our numbers are kind of similar in terms of the square mileage that was produced, but that does not take into account the increased resolution. For example, in FY20, everything that we processed was QL2 or higher, which is just a very significant increase in point density, which makes the processes run quite a bit slower. So by FY19 and most of FY18, we were primarily using GDAL and PDAL for all of our actual processing. And Andrew began the work that he talked about in the second half of his presentation, building the Elevate web application, transitioning off of WMX and going to a bit more of a flexible and distributed processing environment rather than having users click next on a desktop application to run all these tasks. That kind of began in FY20. We went into production with that application in May, and at that point we had approximately finished 155,000 square miles, which was just a fraction of our goal. Those last 4 months of the year after Elevate Web came out, we processed 65% of the year's actual data. We had, I don't think I might have this on the next slide, but we had previously our records, and someone from Ops can correct me if I'm wrong on this, Jeremiah, but prior to the rollout of Elevate Web, the average or the highest record months in terms of area produced or processed was around the 40,000 to 50,000 square mileage mark. And after Elevate Web came out, we had, I think, more than 1 month where we were over 100,000 or at least over 90,000 miles. So we essentially doubled our production numbers there. And we've seen that increased performance across all of our workflows on all of our products using this approach. And really at this point, our software is no longer the bottleneck in any way. And it's just a matter of how much data you have staged and ready to throw at it, which is a very good feeling as a development team.
Hey, Josh.
Yeah, go ahead.
I just wanted to clarify one thing real quick. So if you went back and you looked at, like Andrew's, don't switch the slide, but looking at when Andrew mentioned he was comparing like the COTS or the Esri tools to the open source and kind of showing things in seconds, that was a really zoomed in look. And so those, you might think, well, you get a few seconds of benefit there. Multiply those by huge numbers, because those resulted in more than just seconds of time savings. Those zoomed out then into reality, those equated to hours of time savings in the processing, things that get ran over and over and over again really quickly. So just wanted to clarify that's kind of part of what was going on there.
Mm-hmm. Absolutely. A lot of those processes, even though they only take a few seconds to run, even in the previous versions, those things would be running in parallel. They were being ran thousands of times, and so shaving off just a few seconds, and really, if you look at in terms of percentages, how much of a reduction in runtime those alternative tools were, you can see that it was a massive increase in speed. So thank you for bringing that up, Scott. Okay, so in terms of future goals, we learned a lot of lessons over the last few years with Elevate, and as a team, all the applications we write have really been affected by the early complications of Elevate and the successes we've had in the last few years making these transitions. One of the other main applications that we've kind of taken these lessons learned and applied it to is validate. The data validation process, essentially they're, the users are reviewing the incoming data from the contractors and identifying errors, and then they generate a report to send back to a contractor in case if there's anything that needs to be fixed. Previously, we were using Microsoft InfoPath for generating those PDF reports, and we weren't logging any of that information in a database environment in terms of what errors were found, which contractors this data was coming from, which what areas these errors were being found in, that kind of thing. And so a few years ago, we set out to build a web application to assist in generating those reports for our users, but also for our management staff and us developers, being able to log those actual results in a database environment where it's easier to build higher level reports on the overall reviewing process. And we've taken a very similar approach to how Elevate's set up, and we've also began using Validate to queue some of we have some individual QC tool processes that our users run on the data to perform some data sanity or data checks and make sure everything looks good. We're using this web application to queue up those tasks behind the scenes, just like Elevate is. We actually just went into production with this application a couple weeks ago, and so far it's been going very smooth, and we're excited to see what kind of performance increases we'll see there with that. And so really going forward for both these, kind of the product generation workflow and the data validation workflow that my team writes software for, we're really just looking to identify other parts of that workflow that can be automated and improved, and then building applications or expanding Elevate and Validate as applications to fill those roles. One of the main ones that's kind of on our radar is data ingress. We right now, most of our data from contractors comes in on drives that are shipped in the mail, and just keeping track of those and making sure that we get the right data coming in, and just that whole process could very much use some improvement there. So we're investigating whether we can leverage a cloud solution there where we have a shared data space with the contractors, or just automating that process where we can somehow transfer that data over the network. A lot of questions to be answered there, but we're that's one of the next things we're looking at. And then in addition to that, compression of idle data during the data validation review. So when a project goes back out for corrections, it gets marked in the database that it's not being actively reviewed anymore, and we can take our local copy of it, compress it to save on storage space, and then unzip it when the corrections come back in and we need to do another round of review on it. And then just in general, as IT continues to expand and improve on the hardware available to us, we want to make sure we take a flexible approach and a containerized approach, similar to what we've done with Elevate and Validate, with all the tools we write, so we can make fully take advantage of whatever environments made available to us, whether that's a converged architecture like Derek was mentioning in his slides, or a cloud environment. Whatever it is going forward, we just want to make sure our software is as flexible as possible. And yeah, so that's pretty much everything we've got. Derek already shared some links previously where you can kind of get at our data. I shared a couple others here that Jeremiah recommended I put in. So we have the LiDAR Explorer website. It's kind of a data catalog for browsing what's available. A link directly to the S3 bucket that has all of our data, but in addition, you can download the LPC from there. It is request for pays out of that location. If you're interested in getting a free download, you can access it off of Rocky FTP. And this application is also open or available. There's a link directly to this page, this last page, in the LiDAR Explorer itself. But Howard Butler's Hobu, they've made available all of the data. Sorry, I was reading the chat. I think we're going to share the slides out to everybody, and if not that, we'll at least send out all these links. So yeah. But yeah, that last link, entwine.io or usgs.entwine.io. It's a browser-based LPC viewer. If you go to that URL right there, it has a display of all the LiDAR that's available currently in our request for pays bucket, and it's viewable in your browser. It's a pretty awesome web app that Howard Butler's team has put together. I recommend taking a look at it. But yeah, if there's any questions, we'll do our best to answer them. And thanks for taking some time to listen to us. So
that was great. Yeah, I do want to open it up to questions, and I also want to just kind of provide an opportunity. I know we have our folks from Ops on. If Jeremiah or Josh Nimitz wants to just add any comments here. Really, we produce, development produces these products for ops to use to produce the elevation products that the general public can retrieve and utilize. And I wanted to see if either Josh Nimitz or Jeremiah wanted to say anything.
This is Jeremiah. I won't take away from too much time or questions, but I just want to say I've seen this process evolve over the last few years, and there's been a lot of efficiency gains. A lot of the flexibility that's been really good. Andrew kind of gave me a little PTSD. Talking about all the file locks we used to deal with and the WMX stuff. I was part of all that, and I'm just excited for the future and where we can take this product, because it's had a lot of great work done on it.
Thanks, Jeremiah.
Yep.
All right. Any questions out there? Sorry again for the technical difficulties we had at the beginning of this. This is recorded, and we will send out the presentation slide deck as well. So I'm hoping that everyone will have access to the links and the slides that you might have missed if you joined late. Any questions out there? You can either post it in the chat or come off mute. Okay. That really concludes our presentation. Really, again, appreciate ESIP making this format available to us, allowing us to record and eventually upload this to YouTube. It is great for us as a center to have this platform and format to let the broader community know about our efforts. Megan, I'll let you close us out.
Yes, I'll just say thank you very much to everyone for being here today. This webinar was recorded. It'll be posted to the ESIP YouTube channel, and we'll be sure to share it in lots of places along with the slides. And just a quick plug, next week, Friday, February 19th at 2 p.m. Eastern, ESIP will be hosting our meeting highlights webinar. It'll be a number of fast-paced report outs from the recently held ESIP winter meeting. So if you all are curious to know what other ESIP collaboration areas are doing, that would be a great place to show up. And you can check out esipfed.org/telecons to get the connection info for that. Otherwise, I look forward to next month's webinar.
Thanks so much.